method of dealing with triangles that are not right triangles. One of them is called Law of Sines, and it works really well for good old geometry. AAS, proving triangles congruent, angle, angle, side. It's also really good for finding the length, angles, and sides of a triangle that can be proven with angle, side, angle. Now, both of those give us congruent triangles, which is really nice because it guarantees one triangle. There's one other, and I'll spell it backwards here, but I usually tell my students that if you spell out a bad word, then it's a strange case. This one is considered an ambiguous case because it doesn't prove a right triangle or a triangle is congruent to another triangle. So this one is going to be the tricky one. It might give us a triangle, it might give us no triangle, it might give us two triangles. But these two up here are guaranteed to only give you one triangle. So let's see how these are all going to work. So I have this little triangle over here. It's not a right triangle, but I have dropped an altitude. And altitudes in right triangles are always perpendicular to their base. So it drops from a vertex straight down. Now, this one I've drawn an altitude that's inside the triangle. If we had an obtuse triangle, we could drop it outside a triangle, and it's still, the same idea. It's an altitude. All right, so with this altitude, I'm going to set up some trigonometry. So the first thing I'm going to do is concentrate on angle A here. So if I look at angle A, and since this is law of sines, we're going to set up sine functions. So sine of the measure of angle A is equal to opposite, which is h, and hypotenuse, which is c. So this would be h over c. So if we solve for h, we'd get h is equal to c times sine of A. I really should, do a little designation here. Measure of angle A. All right. And we can also do that from the other side. We can look at angle C here. Now, if we're looking at angle C, then opposite is still h, and the hypotenuse now is A. So I would set up sine of the measure of angle C is equal to h over A. And again, if we solve for h, we would get h is equal to A times sine of the measure of angle C. Okay. Little c and big C are two different things. Big C is the vertice, little c is a side. So another thing to notice is if you look at vertice A, if you go completely across the triangle, you see this little a. And if you see vertice C, completely opposite it is little c. And then B up here, of course, opposite it is little b. It's just a way of assigning letters to a random triangle. All right, so this and this are both equal to h. Therefore, we can write c times sine of A, I'm going to drop the measure of the angle, is equal to A times sine of big C. Now, one thing this is called is a proportion. Now, generally proportions are written as fractions. So if I kind of move the C to that side and move the A to that side, what we get is sine of the measure of angle A over A is equal to sine of C over C. And this is known as the law of sines. Now, of course, if I just, reverse the order of B and C and dropped an altitude from C, we'd also get this equal to sine of measure of angle B over B. So they're all equal to each other in proportion, and you can set any one of them equal to the other. Now this setup, where the sines are on top, usually if you're looking for an angle. If you're looking for a side, it is actually better to set these up the other way around. So it would be A over sine of A is equal to C over sine of C. And this is legal because we're reciprocating both sides of the equation. And if you cross multiply, you end up back at our multiplicative idea of a proportion. So both of these are considered law of sines. One of them for angles, the other one for finding sides. It's just easier to do it this way. You could use the angle one for the sides. It really doesn't matter. So here's one of the examples for law of sines. If we have a general triangle ABC is given where the side A is 18 centimeters, the measure of angle A is 119 degrees, and the measure of angle C is 20 degrees. When we say solve the triangle, remember it's finding everything else. We're given 3 pieces of information. We're looking for the other 3. So I'm going to draw in here. Now, this is just a general picture of the triangle. So when I put in here 119 degrees at angle A, obviously that is definitely not 119 degrees because 119 is an obtuse angle and my drawing here is acute. But it really doesn't matter because what we use the picture for is to see where things need to go. So the measure of angle A is 119, the measure of angle C is 20 degrees, and then side A is 18 centimeters. So these are all the given information. And it's always best, if you can, to always use given information to find answers rather than found answers, because those will be rounded and we might end up with rounding error. All right, so let's see what we can find here. If we tried to set up, sine of A over A and so forth and so on, here the first thing we're going to be looking for is sides. So my formula, I'm going to put the little letters up top and the signs in the bottom. Second thing to notice is we're given 2 angles, so it's probably always best to find the third one. So to start off with, the measure of angle B is going to equal 180 degrees minus the sum of the other 2 given angles, 119 degrees and 20 degrees. You can also just subtract 119 and subtract 20 to get to your answer. So the measure of angle B is equal to 41 degrees. So I can put that in my picture. It might actually help out later on. All right, so I guaranteed to have 3 angles of a triangle now. Let's see if we can set up law of sines for one of the sides. So the given angles are A and C, so definitely sine of the measure of angle A and sine of the measure of angle C, because they're given anyways. And then up top, we're going to put the measure of A above the sine of A, which is 18. And then on top of sine of 20, the only thing I have is C. So this would be the setup to find the side C. So we're going to cross multiply is one way of going about it, but also if you think about it, I'm just trying to solve for C here. So all I have to do is move the sine of 20 up, basically multiplying both sides by sine of 20. So this is going to give me C is equal to 18 times sine of 20 divided by sine of 119. Okay, so 18 sine of 20, sine of 119. And we get 7.04, but I'm just going to write it to the nearest tenth. So we got 7, approximately 7 centimeters. All right, so I'll write that in my picture, and I'll definitely put approximate next to it because I want to remind myself that wasn't given, that was not a given side. All right, so now we have side C. The only other thing that's missing is side B, so we'll do the same thing. And I'm going to just use the A setup to find the third side. Oh, one thing I forgot to mention was make sure your calculator is in degree mode when we're working degrees and radian mode when we're working in radians. Otherwise, the answer is not going to make much sense. All right, same thing. We're going to move this piece up here to get B by itself. Technically multiplying both sides by sine of 41. And get an answer. So that turned out to be 13.5. So approximately 13.5 centimeters. So this side would be 13.5 centimeters, and we have just solved the triangle. We have all three angles, and we have all three sides. Now, I forgot to say on this one, when we're given side A, angle C, this is the setup for, let me do it in a bright orange, angle, side. So this was an example of angle, side. All right, so for this example, I have A is 10 inches, so I'll put that over here. Angle B is 69 degrees. Angle C is 79 degrees. So there's that angle, there's that angle. And this setup obviously is angle, side, angle, 69, 10 inches, 79. So this is an angle, side, angle setup. Now, it's not necessary to know those because sometimes when you're just plugging, or at least attempt plugging into a formula out of the two that we're going to have today, it'll be really recognizable which formula you have to use, because if you plug in what you know into one formula and you're still left with two variables, then it must be the other one, or you're missing some information. So let's set this one up. And if we try right away to set up, A over sine of A is equal to, let's say, C over sine of C, you can see right away that if we try to do A over sine of A, which is over there, or A over sine of A is this way, and then we try to do C over sine of C, you're going to see that we have two missing variables, the C and the A. So before we can start doing that, it's best if we have two of the angles to always go find the third. That way you don't fall into, getting lost. So the measure of angle A is equal to 180 degrees minus the sum of the two other angles, 69 and 79. So it's 32 degrees. All right, so the measure of angle A is 32 degrees. And we can put that in our picture. Now this one is an exact answer. It's not a rounded answer, so I'm not going to put the little approximate sign. Oops. All right, so now we can set it up. So I can do A over sine of A, because I know those two pieces, and I can do C over sine of C. And that leaves me only one variable left over, which is C. So A being 10, sine of A being sine of 32 degrees, is equal to C, which I don't know, over sine of the angle C, 79 degrees. And then C is going to equal 10 sine of 79 over sine of 32. So now it just becomes like the other problem. So about 18.5. inches in this case. So side C is approximately 18.5 inches. All right, and then that leaves just side B, and that's pretty easy. You start off the same with sine of A over A equals sine of B, or I'm sorry, B over sine of B, which is 69. So sine of 69 degrees. And then, of course, B is going to equal 10 sine of 69 over sine of 32 degrees, 69 degrees. All right. So if you use your up arrow in your calculator, you can just change the one number that needs to be changed, as long as you use the a over sine of a, or the same setup you used for the first one, to get the second answer pretty quickly, 17.6. So this is approximately 17.6 inches. And therefore, we have found each piece of this right triangle, even though it wasn't a right triangle. All right. So here we have triangle ABC has side A is 42, side B is 37, and the measure of angle A is 43 degrees. So if I put that information into the picture, B is 37 centimeters, and A 42 centimeters, then this becomes the setup of side, side, angle. And if we're dealing with side-side angle, then that is the ambiguous case, and we have to be really cautious with this one. So what this means is can have no triangles, one triangle, or two triangles. And there's special reasons why each one of these exists. An easy way to think about it is if I give you an infinite side, and then I say, oh, I have this angle here, and this is fixed. And then I say, well, I have this side, and this length is fixed. And I make this side too short, that would be no triangles. If I make this side a bit longer and hit the third side, then I definitely have one triangle. But if I think of it as a pendulum, it would hit over here also, swinging back in this direction. So that actually would turn into two triangles. And then if side A is really long, it's only going to hit the third side once, and that guarantees one triangle. So this is where it's all coming from. But it's actually easier to see from the numbers that are generated how this all comes about. So let's see what happens to this triangle. And I'll give you clues on how to find out if it's no triangles, one triangle, or two triangles. All right, so let's set up what we can. Now, what we're going to be looking for here is an angle. So because I have side A and side B, the only angles I can work with are angle A and angle B. So I'm going to have to find angle B first. There is no way of finding angle B other than the law of sines. So I'm going to do sine of angle B over its opposite side, which is 37. Now notice I'm flipping the formula here because I know I'm looking for an angle, is equal to sine of A, which is 43 degrees, over side A, which is 42 centimeters. All right, so now we have to solve for the measure of angle B. So the first thing we're going to solve for is sine of B. So sine of B, we're just going to multiply both sides by 37, is going to become 37 sine of 43 degrees over 42. All right, so 37, 43, 42. So 37 times sine of 43 over 42 in degrees. Oh, I'm sorry, this isn't degrees. This is just a number. Be careful. This is 0.6008. And generally, we're just going to leave this number in our calculator and do something to it. If you've just typed this mess into your calculator, is to hit sine inverse, which of course is second sine, and then you're going to hit second, the negative sign, basically second answer, and then you can hit enter. Now, one thing I want to talk about this answer is it's definitely less than 1. Now remember, if we're doing sine inverse of this number, which is a ratio, then the ratio cannot be bigger than 1 or less than negative 1. So if the number turns out to be bigger than 1 or less than negative 1, that's the case of no triangles. If you type the whole thing in with the sine inverse in front, then what will happen is it'll come up with a domain error, and that's no triangles. So let me get the sine inverse in front here. And we find that the angle is 36.9 degrees. So B, the measure of angle B, is going to equal sine inverse of this mess. And that turned out to be, I don't have to go back, approximately 36.9 degrees. Okay. Now, here's where sine gets a little tricky. Change color for a second. If we were looking at sine inverse only works in the first and the fourth quadrants. But sine is positive in the first and the second quadrants, all students. So there are two possible angles for this 36.9. It could be in the first quadrant, or it could be in the second quadrant with a reference angle of 36.9. And this is why it's considered the ambiguous case. We're not sure if it's an acute angle or an obtuse angle. So to find out what the obtuse angle is, this measure here, we're going to have to take the 36.9 and subtract it from 180. And this becomes known as the supplementary angle. And it is a possible angle that this triangle has, and this is how you determine whether it's one or two triangles, is from this first answer. So 180 minus 36.9 is 143.1. All right, so this is 143.1. So the test is, if this is the second angle, this is I'm just going to call it angle B sub. If this is the second B angle, and we already have 43 degrees taken up in the triangle, then can I have it as 143.1? So the test is, if I add the subangle plus the original angle, what does it give me? Well, this gives me 186.1 degrees, which is definitely bigger than 180 degrees. A triangle can only have 180 degrees. So the supplementary angle is not going to give us a second triangle. And that's all we need to know. So this is a one triangle situation. So the only angle B is this one. So it only has one triangle. And then you can solve for the angle C, of course. So angle C is going to be equal to, based on angle B's approximation, I should make that approximation, it would be degrees. So now we have three angles, A, B, and C, so that leaves us one side, side C. So we're going to go C over the sine of 100.1 degrees is equal to, let's take a given one, sine of A, so sine of 43 degrees, and then A is 42. Now notice I used the given angle and a given side rather than one of the rounded angles, and then solve for C. So C is going to equal 42 times sine of 100.1 degrees over sine of 43 degrees. 42, 43. So about 60.6. So C is approximately 60.6 centimeters. 60.6 centimeters. Now, another thing to check out is, and it'll help later on, the biggest side has to be across from the biggest angle, and the smallest side should be across from the smallest angle. So the smallest angle here is 36.6. Let's go with yellow. And 36.9, sorry. and opposite it is 37 centimeters, and the biggest angle is 100.1, and opposite it is 60.6. And it makes sense that 60 is the biggest number in the entire triangle sidewise, and it's across from 100. And 37 is the smallest side of the triangle, and it's across from the smallest angle. It's a good check, so you can kind of see that your work is right. All right, so in this one we have A is 31 centimeters. B, I forgot to put centimeters next to these guys. And B is 37 centimeters. Really doesn't matter what the measurement is. And A is 32 degrees. All right, so if we look for this one, this setup is side, side, angle again. So that's the dangerous one. Angle, side, side, or side, side, angle, ambiguous case. So I don't know if it has one triangle, two triangles, or no triangles at all. So let's set up what we can in this triangle. And the major setup is we know everything about the side A and angle A. So that's always going to be part of my process of finding the rest of the information. The only other part I have is the B side. So the only angle I can find is angle B. So I'm going to set it up as sine of angle B divided by side B, which is 37 centimeters, is equal to, and I'm going to stick with sine of A over A for most of this problem, sine of 32 over 31 centimeters. All right, so when we find the measure of angle B, it's going to be sine inverse of, and that 37 we're going to multiply both sides by, so it's going to be 37 sine of 32 divided by 31. So that's going to give us approximately 39.2 degrees. So this is approximately 39.2 degrees. Now, the reason that this becomes ambiguous is that B angle. Remember, it's either itself or its supplement. So we also have to go and find angle B sup. So angle B sup is just 180 degrees minus 39.2 degrees. And we're going to call this an approximation, even though we think 39.2 is a solid number. So 180 minus 39.2 is 140.8. Oops. So this would be approximately 140.8 degrees. Okay. Now, the test, of course, is going to be whether this constitutes a triangle. So we're going to take our B sup, we're going to take our original angle, and we're going to add them together. So we get 140.8 plus 32, and that gives us 172.8 degrees, which is fine because it's less than 180 degrees. So this is the two triangle case. So we're going to get two triangles out of this mess. All right, so we're going to have to be really careful at this point. So because it is two triangles, we're going to separate this into two possibilities. Triangle number one, and over here, triangle number two. And I usually separate them so I can keep my information straight. Now, triangle number one is going to use angle B that we calculated. That's this one here, the 39.2 degrees. So here we're going to have angle B for this one is going to be 39.2 degrees. Angle B for the other one is going to be B sup, which is 140.8 degrees. Oops, let's label this right. Angle B is on this side is going to be 140.8 degrees. All right, so given those two pieces of information, we should be able to figure out what angle C is and the last piece, which is side C. Okay. So to find angle C, that's the easy one. We already have two angles of the triangle, angle B, angle A. So angle C is going to equal 180 degrees minus the sum of the given angle and my angle B here. Oops, 2 degrees. And that's equal to 108.8. Okay. So then we can go through the process of finding side C using the law of sines. So I'm going to set it up as C over the sine of this angle I just found, C, is equal to, and then remember I said A over A is going to be the one we want. So side A over sine of angle A. And then C is going to equal 31 times sine of 108.8 divided by sine of 32 degrees. So C for this case of the triangle is going to be approximately 55.4 centimeters. So for triangle 2, we also have to find the measure of angle C, and we're going to do it the same way. So the measure of angle C is equal to 180 degrees minus the sum of the given angle and this other angle B sub. And we're going to find that this angle C is 7.2 degrees. All right, and then the setup actually stays exactly the same. The only thing that changes is the angle. And the A over sine of A stays the same. So finding the other one, again, just up arrow in your calculator, change the angle from 108 to 7.2, and get a nice answer. So this would be 31, 7.2. So 31 times sine of 7.2 divided by sine of 32 is about 7.3. So this side C would be approximately 7.3 centimeters. And that gives us our two triangles. So triangle number 1 is special because angle B is different, and side C will be different than triangle number 2, where B is an obtuse angle and C is a really small side. So this is why the ambiguous case, you have to be very careful. Now to talk about the law of cosines. It's another one of the laws that will help us solve a triangle that is not a right triangle. All right, so here I have a picture, and I've drawn it so that the radius of a circle is C. At this point, B is on a circle. It's not the unit circle. And what I want to do is find the coordinates of B. So the first thing I'm going to do is drop an altitude down here, and we're going to be calling this the y coordinate of B, and then the entire base here from here to the origin is going to be the x coordinate of B, and then we're going to call this angle over here theta. Okay, so then we can say that the sine of theta is equal to y over c, and that implies that y is equal to the radius times sine of theta. And the cosine of theta would be adjacent over hypotenuse, and that would be x over c, and that implies that x is equal to the radius of this circle times cosine of theta. So it kind of makes sense that the x-coordinate has a cosine in it and the y-coordinate has a sine in it. So the coordinate of B is literally c times cosine of theta, comma, c times, get that a little darker, sine of theta. All right, so the other 2 points, A is real easy, is 0, 0. And C we're going to label as A, comma 0. Oh, I'm sorry. That's B, comma 0. the length of this side as being b, then that must be b0. So now if we try to find the distance between point B and point C, in other words, the length of little a here, this distance, then we can set up a distance formula between these two coordinates. So we would get distance is equal to the square root of the change in x squared plus the change in y squared. And the change in x in this case and d in this case is my little letter a, so I'm going to get a is equal to the square root of, draw this out, and then the change in x is going to be the x-coordinate of point B minus the x-coordinate of point C, so it's going to be c cosine of theta minus b, and this will be squared, plus, and then we're going to get c sine theta minus the y-coordinate down here at point C is just 0 and squared. Now one thing I don't want to write over and over again is that square root symbol. So I'm going to square both sides, and I'm going to get a squared. And then I'm going to square out the first term. So this is c squared cosine squared theta minus 2bc, because we'll multiply the b and the c twice with the cosine of theta. And then finally plus b squared. And then the last term is just going to be c squared sine squared of theta, because the minus 0 is not going to affect anything. So it's foiling out c cosine theta minus b, and it's just squaring c sine theta. All right, so now we can kind of group a few things. The one thing I want to group for sure, because I see it, is a sine squared and a cosine squared. And both of them have a c squared attached to it. So I'm going to factor out a c squared and see what's left behind. So I'm going to get a squared is equal to c squared parentheses cosine squared theta plus sine squared theta. And that'll take care of those two terms. And then I still have my minus 2bc cosine of theta. Okay. Now, of course, sine squared plus, and I'm missing my plus b squared. All right, now cosine squared theta plus sine squared theta is 1. So this turns into a squared equals c squared minus 2bc times cosine of theta plus b squared. All right, so now I just need to rearrange things, and I get the law of cosines formula is a squared equals b squared plus c squared minus 2bc times cosine of theta. And this is just one of the choices for the law of cosines. So basically, one thing I'm going to change in the formula right away is I don't want to call this theta anymore. Okay, I do want to call it, let's change color to emphasize that theta is also known by its other angle name, A. So this would be cosine of the measure of angle A, vertex A. So one thing to notice about the law of cosines is it starts with an A on one side and it ends with the other A on the other. So this formula can also be written as b squared equals a squared plus c squared minus 2ac times cosine of big B. It also can be written as c squared equals a squared plus b squared minus 2ab times cosine of angle C. So depending on how you want to look at it, if you want to go by pure labels, then these are the three formulas. But I always just try to remember it that if I'm looking for this side, then I need to work with the opposite angle. So if you're looking for side C, its opposite angle is vertex C. All right, so this is the law of cosines. So this law of cosines works for two of the provable congruent triangle setups. one of them being side angle side, and the other one being side side side. And one of the things that's really important for law of cosines, if you don't use law of cosines all the way through, because eventually we're going to go back to law of sines, it's much easier to calculate, is we're going to be looking for the largest angle. So when you're working with law of cosines, you're always looking for the largest angle. So if I gave you some sides of this triangle are like 17, 25, and 30, then the largest angle is going to always be across from the largest side. So angle B here is the largest. And the smallest angle is always going to be across from the smallest side. So 17 is the smallest of the sides. So angle C would be the smallest. Now, when you're talking about law of sines, you either want to use the smallest or the second smallest. You definitely do not want to use the largest because of that ambiguous case. So whenever you have a choice between angles to find for law of cosines, you go for the biggest one. If you have to choose law of sines to find an angle, you always go for the smallest or the second smallest one. And that way you don't fall into that trap of the ambiguous case. It gets very tricky then. All right, so let me get rid of all of this. Come up with a nice example. All right, so for example, let's say we have side A is equal to 14 centimeters, side B is equal to 17 centimeters, and angle C is equal to 37 degrees. All right, so by the law of cosines, what we're given is a side, an angle, this is 37 degrees, and another side over here, 17 centimeters. So this is the side angle side setup. All right, now because we're given angle C, vertice C here, the side that we have to find under law of cosines is the one opposite of it. So the formula is going to become c squared equals a squared plus b squared minus 2ab times cosine of c. So that's the formula we need to use because we have we have the angle c and we have a and b. So we have everything on the right-hand side of the equation. All we have to do is solve for, c by itself. All right, so let's plug in what we know. So c squared equals a is 14, b is 17, and then it just becomes 2 times 14 times 17 times cosine of 37 degrees. All right, now before I go typing that into my calculator and hit an enter, realize that there's a square up here. So our final answer is going to be the square root of all of this mess. So it's better if you just type it in, starting off with the square root and then all this mess behind it to get an approximation for C. So when we do the square root of this thing, we're ending up with 10.2. Now, when we delete, oops, I shouldn't have done that. When we delete all of the decimals from this number, we're rounding the answer. And one of the problems with law of cosines when we go further into it is this being a rounded number for this side, change colors here, is going to affect some of our answers later on. So you might not get a perfect answer from here on out, which is okay because we have no other choice. If you want a better answer, then you keep more of the decimals. So that one we're going to leave as 10.2, and then we're going to use law of sines to find either A or B. Now the one you should go for is the second smallest angle. So 10.2 is definitely the smallest side, so 37 degrees is the smallest angle. The next smallest side is 14 centimeters, so using the law of sines, we really should go for angle A first. So to find angle A, we're going to set up law of sines. Sine of A over its opposite side of 14 is equal to sine of a rounded, sine of 37 over a rounded side. And this is where our small error is going to come in, that 10.2. All right, So multiply both sides by 14 and then sine inverse. So the measure of angle A is going to equal sine inverse of 14 sine of 37 divided by 10.2. So when we type that into our calculator, we're getting 55.7, approximately. 7 degrees is for angle A. So that gives us angle A. And then, of course, angle B is real easy. We just have to do the subtraction thing. So angle B is equal to 180 minus the 55.7 we just found, plus the original angle of 37 degrees. And we'll end up with 87. So angle B is equal to 87.3 degrees. Now that wouldn't have caused a problem with the second possible triangle, the ambiguous case, but you wouldn't know until you tested it out. The other thing is, if you did find angle B first and then angle A second, it wouldn't be these same exact numbers. It would actually be 87.6 for B, and then that would leave 55.4 for A. So that 10.2 being rounded does change the answer from one side or the other. So it's just one thing to be mindful of. Another example of law of cosines would be this one where we have the three sides. So this would be the case of side, side, side. And this one you have to be really careful. You want to concentrate on the largest side. So here we have the largest side is B. So if B is the largest side, then the angle that we're going to find under the law of cosines is going to be the biggest angle. So we're looking for angle B before we're going to go looking for angle C or angle A. So if angle B is what we're looking for, then our formula is going to be B squared equals A squared plus C squared minus 2 times A times C times cosine of the angle B. Now remember, the beginning letter and the ending letter have to be the same for law of cosines. And then plug in what we know. Oh, hold on, we get my picture up to date. 9 centimeters and 10 centimeters. Okay, so B is 17, so this would be 17 squared. A is 10, and 9 for C. So that would be minus 2 times 10 times 9 times cosine of the unknown angle B. All right, now you can sit here and grind this all out to get B by itself, but I think there's a step that you can take to make your life a little bit easier. And that step is, this piece is negative on the right-hand side. This piece is positive on the left-hand side. So if I move the 17 squared to the right, and I move this chunk over to the left, all they do is change signs, so it looks like they're just switching positions. So this becomes 2 times 10 times 9 cosine of B is equal to 10 squared plus 9 squared minus 17 squared. All right. And then, we can get B by itself by dividing both sides by this piece. And we'll go back to the other color. We'll get, cosine of B is equal to, and in a calculator, it's really important that you write the parentheses for the numerator and the denominator. That way you don't make a mistake when you type this in. And if you want, you can change 2 times 10 times 9 into a singular number, but this is in case the numbers just get atrocious. And of course, we're going to cosine inverse both sides, and we'll eventually get to angle B. So this would be cosine inverse of 10 squared plus 9 squared minus 17 squared all over 2 times 10 times 9. And again, I highly suggest parentheses around the entire top and parentheses around the entire bottom so that you don't make any grouping errors. And if you type that into your calculator, you're going to get the measure of angle B is equal to, so B is going to be approximately 126.9 degrees. All right, so then the rest of it is law of cosines, or I'm sorry, law of sines. So we now want to find the smallest angle. So we have angle B, and the smallest angle is going to be across from the smallest side. So we're looking for angle C. And the only other opposite sides that we know about each other are these B's, the side B, and now we have found angle B over here. So we're going to set up sine of C over 9 is equal to sine of B, which is approximately 126.9 degrees. Now, when I say that approximately, that means we're going to get rounding error in our answer. So that sometimes throws things off. The opposite side being 17. All right, and then go through the process of finding C. So this will get us down to the measure of angle C is equal to sine inverse of 9 sine 126.9 degrees over 17. All right, and then type that into our calculator. And you'll notice that it wasn't that important to group in this calculation as it was in the other one, because all the operations are multiplication and or division. The law of cosines has addition and subtraction, so that makes it a little bit more tricky. So here we get the angle is equal to about 25 degrees. So angle C is approximately 25 degrees. All right, so that gives us a second angle. This is our first angle over here. So that leaves just the third angle. So if we do our little subtraction thing, so angle A is equal to 180 minus 126.9 plus 25, we'll end up with the measure of angle A is equal to we'll end up with 28.1 degrees. All right, so this becomes 28.1 degrees. And therefore, we have solved this oblique triangle. We have 3 angles, and we were given 3 sides.